Meet Mr. John. He owns a stationery shop. On the eve of Children's Day, he displays stationery for students on a board. It shows that the cost of 1 pencil, 2 erasers and a sharpener is 13 rupees. The cost of 3 pencils, 1 eraser and 2 sharpeners is 19 rupees. Similarly, the cost of 2 pencils, 1 eraser and 1 sharpener is 12 rupees. The offer pulled in many students. Ryan was one of them. Being very intelligent and curious, Ryan thought of first calculating the cost of each article before purchasing them. So he begins by expressing the given information as a system of linear equations. Let the cost of a pencil, an eraser and a sharpener be X rupees, Y rupees and Z rupees respectively. Then, from the given data, the set of equations in 3 variables shown here can be obtained. Rearranging the equations in a matrix form, we get the equation as shown. Let's now learn to solve such systems of linear equations using the inverse of the coefficient matrix. Consider the system of linear equations in 3 variables as shown. In matrix form, this system of equations can be expressed as shown here. Let us denote the 3 by 3 matrix on the left-hand side by A, the column matrix on the left-hand side by X, and the column matrix on the right-hand side by B. So, equation 1 can be rewritten as A into X is equal to B. To solve this system, we have to find the values of the 3 variables X, Y and Z. In other words, we have to find the column matrix X. 2 cases arise while solving this equation. The first case is if the coefficient matrix A is non-singular. If A is a non-singular matrix, then A inverse exists. Multiply both the sides of the equation AX is equal to B by A inverse. We get the equation as shown. On simplifying, we get X is equal to A inverse B. This matrix equation provides a unique solution for the given system of equations, as the inverse of a matrix is unique. Such a method of solving a system of linear equations is known as the matrix method. The second case is when the coefficient matrix A is a singular matrix. In this case, the determinant of A is 0. Consider X is equal to A inverse into B. Now, A inverse is equal to adjoint of A divided by determinant of A. So we have X is equal to adjoint of A into B divided by determinant of A. While solving this equation, 2 cases arise again. That is, adjoint of A into B is either a 0 matrix or a non-zero matrix. If adjoint of A into B is a non-zero matrix, then the system of linear equations is inconsistent. In other words, the system of linear equations has no solution. On the other hand, if adjoint of A into B is a zero matrix, then the system of linear equations is either consistent or inconsistent. Accordingly, the system of linear equations has either infinitely many solutions or no solutions at all. Let's now apply the matrix method to solve Ryan's problem. The arrangement of the given data in matrix form is as shown here. Let us denote the 3 by 3 matrix on the left-hand side by A, the column matrix on the left-hand side by X, and the column matrix on the right-hand side by B. So, we have AX is equal to B. This implies that X is equal to A inverse B. Hence, to find the cost of each article, we have to find the product of A inverse and B. Let's begin by finding A inverse. First, let us check if A inverse exists. First, we have to find the determinant of the given matrix. Determinant A is non-zero. This implies that A is a non-singular matrix. Hence, A inverse exists. Let's now calculate A inverse. Adjoint of A is obtained by finding the transpose of the matrix obtained by replacing the elements of matrix A by their corresponding cofactors, which is as shown. Now, A inverse is equal to adjoint of A divided by determinant of A. On evaluating A inverse, we get the matrix as shown. Finally, finding the product of the matrices A inverse and B, we get a column matrix with the elements 2, 3, and 5. This implies that X is equal to 2, Y is equal to 3, and Z is equal to 5. Hence the cost of a pencil, an eraser and a sharpener is 2 rupees, 3 rupees, and 5 rupees respectively. After calculating the cost of each article, Ryan feels quite happy. He bought some pencils, erasers and sharpeners and went home happily.